Imagine walking into a brand new, luxury high-rise apartment. The walls are freshly painted, the view is spectacular, and the price tag was your life savings. You lean against a concrete pillar for support, but instead of solid stone, your hand punches straight through it, crumbling the material like a dry biscuit. Imagine watching a construction worker take a thick bar of solid steel, the structural skeleton meant to hold up a skyscraper, and snapping it in half with his bare hands as if it were a twig. This isn't a movie set, and it isn't a demolition site. This is the terrifying documented reality of modern construction in China. They have a specific name for it: Tofu Dreg projects. The term comes from the leftovers of making bean curd, soft, mushy, and structural garbage. Driven by unprecedented speed, systemic corruption, and a desperate race to boost GDP figures, massive infrastructure projects, from bridges and dams to mega towers housing thousands of families, are being built with materials that violate every fundamental law of engineering. The internet is flooded with viral videos of residents picking apart their own homes with their fingernails, or bridges collapsing under the weight of a single truck. But what is actually happening inside the concrete? What is the chemistry that turns a skyscraper into a sandcastle? Today, we are exposing the 4 deadly signs that a city is built from tofu and the science behind the fake materials. 1. The rebar that snaps like glass. 2. The bridges filled with trash. 3. The bamboo steel scandal. And 4. The concrete that turns to sand. Let's tear down the facade. In a world full of fake infrastructure, it's getting harder to trust what you see. The same applies to the digital world. Scammers, hackers, and data brokers are constantly building fake websites and traps designed to look solid until they steal your data. You need a tool that exposes the threats and keeps your connection reinforced. That's why I use NordVPN. NordVPN acts as a verified reinforced steel barrier for your digital life. It encrypts your traffic so no one, not your ISP, not hackers, not government censors, can see what you're doing. It also has a threat protection feature that blocks malware and fake sites before they can load, essentially stress testing the websites you visit. Don't build your digital life on a foundation of tofu. Secure it with the best. Go to the link given in a description and use code MEGADEFECT for up to 73% off, plus 3 extra months. Our first sign is the most visceral and terrifying visual of the tofu dreg phenomenon: the snap. Rebar, or reinforcing bar, is the backbone of modern civilization. Concrete is fantastic at handling compression. You can pile immense weight on top of it, but it is terrible at tension. If you try to pull concrete apart or bend it, it snaps immediately. That is why we insert steel rebar, to handle the tension and give the building flexibility. Crucially, construction-grade steel is supposed to be ductile. This is a specific metallurgical property. It means that if a building sways in a typhoon, settles into the mud, or is hit by an earthquake, the steel should stretch, yield, and bend long before it breaks. It absorbs the energy. But in tofu dreg projects, we see workers taking thick bars of what looks like steel and snapping them cleanly in half with zero effort. The bar doesn't bend, it shatters. The science behind this failure lies in metallurgical fraud. To save money, corrupt foundries often use illegal induction furnaces rather than proper electric arc furnaces. They melt down low-quality scrap metal, old bicycles, rusty pipes, and industrial waste without properly refining it. This results in steel with dangerously high levels of impurities, specifically sulfur and phosphorus. In metallurgy, sulfur is a killer. It creates iron sulfide inclusions at the grain boundaries of the metal. These inclusions have a low melting point and weaken the bonds between the steel crystals. This creates a property known as hot shortness, making the steel incredibly brittle. Phosphorus does the same thing, reducing ductility and toughness. A proper steel mill spends millions removing these impurities. A tofu foundry leaves them in. The result is a material that looks like steel but behaves like glass. On a stress-strain graph, proper steel has a long plastic deformation zone where it stretches. Tofu steel has almost none. It goes straight to catastrophic failure. In a building, this is a death sentence. If an earthquake hits, ductile steel would save the building. Brittle tofu steel simply snaps the moment the ground shifts. Once the rebar snaps, The concrete has zero tensile strength. The floor slabs detach, the columns buckle, and the building pancakes instantly. Sign 2 reveals the extent of the corruption, the trash filler. In civil engineering, massive concrete structures like bridge pylons, decorative arches, or raised pedestrian walkways are often designed to be hollow or filled with a lightweight, structural honeycomb. This is a legitimate technique to reduce the dead load of the structure. However, in China, whistleblowers have revealed a shocking, fraudulent practice, filling these critical load-bearing voids with literal garbage. The most infamous examples involve polystyrene foam, styrofoam, and compressed plastic waste being stuffed into bridge supports and then thinly coated with a veneer of cement to hide it. This is the honeycombing scam. Here is how it works. A subcontractor is paid to pour a solid, reinforced concrete barrier. But concrete costs money, so they construct a wooden mold, and instead of filling it with rebar and cement, they stack blocks of white packaging foam or piles of construction trash. They then pour just 2 or 3 inches of concrete over the top and sides to hide the evidence. To the inspector's eye, it looks like a solid block of stone, but structurally, it is a shell. Concrete relies on its mass and density to resist impact forces. A bridge rail filled with styrofoam offers zero crash protection. If a bus or a truck hits a proper concrete barrier, the barrier absorbs the impact and deflects the vehicle. If a vehicle hits a tofu barrier, it won't deflect anything. The vehicle will punch right through the thin concrete shell and plummet off the edge of the bridge. We have seen viral footage of pedestrians leaning on stone railings that simply disintegrate under their body weight, revealing compressed plastic bags inside. This isn't just cutting corners, it is effectively building movie props and passing them off as critical infrastructure. The danger is compounded by the fact that these fillers do not bond with the concrete. They create a slip plane inside the structure, a pre-existing fracture line where the wall is guaranteed to fail under stress. Sign 3 takes us back to a pre-industrial nightmare, the bamboo steel. Believe it or not, there was a time in history when using bamboo as reinforcement in single-story mud or adobe structures was a legitimate technique. Bamboo has decent tensile strength for a plant, but in a modern high-rise skyscraper, using it as a substitute for steel is criminal negligence. Yet during the demolition of several luxury apartment complexes in China, rubble inspectors have found bamboo strips used in place of steel rebar in floor slabs and non-load-bearing walls. The scam is simple. The contractor charges the developer for expensive steel, pockets the difference, and embeds cheap wood into the concrete. The science of why this fails is simple: moisture and biology. Concrete is porous. Over time, water vapor and moisture inevitably seep into the walls. Steel rebar can rust, which is bad, but bamboo rots. As the organic material decays inside the wall, it shrinks, turning into compost. This leaves a void inside the concrete, a hollow tube where the reinforcement used to be. The concrete is now unreinforced and riddled with holes. Even worse is the thermal expansion mismatch. Concrete and steel are the perfect pair because they expand and contract at almost the exact same rate when they get hot or cold. This prevents internal cracking. Bamboo expands when it absorbs water. It swells. This swelling exerts internal pressure on the concrete, cracking it from the inside out. Then when it dries, it shrinks, leaving a gap. This cycle of swelling and shrinking pulverizes the surrounding concrete over time. A building reinforced with bamboo is a ticking biological time bomb that will inevitably lose its structural integrity as the vegetable matter decomposes. You are literally living inside a composting bin. Finally, sign 4 is the most common, the most insidious, and perhaps the most dangerous of all: the crumble. You've seen the videos of people poking a wall with a house key, and the concrete simply turns to gray dust and pours out like dry sand. You can dig a hole through a load-bearing wall with a spoon. This is a failure of chemistry known as the sea-sand crisis. Concrete is a precise recipe: cement plus sand plus aggregate plus water. The strength comes from the hydration reaction, where the cement paste binds the sand and rocks together into a synthetic rock. The crumble happens for 2 reasons. First, the ratio theft. Contractors use far too much sand and far too little cement to save money, Without enough cement paste to coat every grain of sand, the mixture never truly bonds. It dries into a weak sandy block that has no compressive strength. But the second reason is worse: the use of unwashed sea sand. River sand, the jagged, clean sand needed for construction, is running out due to massive overmining. So illegal dredgers harvest sand from the ocean floor. Sea sand is smooth, which is bad for bonding, but more importantly, it is full of salt, chloride. If you don't wash the sand thoroughly, which costs time and millions of gallons of fresh water, that salt gets into the concrete mix. This triggers a chemical catastrophe called chloride attack. Chloride ions penetrate the protective passivation layer of the steel rebar. This causes the steel to rust at an accelerated rate. Here is the physics of the failure. When steel rusts, the iron oxide rust occupies 6 times more volume than the original steel. This expanding rust exerts massive internal pressure on the surrounding concrete, up to 4,000 psi. This pressure blasts the concrete apart from the inside, causing it to spall and crumble. A building made with salty sea sand is chemically programmed to destroy its own skeleton within a few years. It creates walls that look solid, but have the structural integrity of a sandcastle waiting for the tide. These 4 signs, the snap, the trash, the bamboo, and the crumble, are symptoms of a system that prioritizes speed and volume over survival. China built cities for millions of people in record time. They poured more concrete in 3 years than the US did in the entire 20th century. But physics does not allow you to cheat without a cost. The Tofu Dreg era has created a legacy of instant cities that are destined to become instant ruins. The scary question is not if they will fall, but when and how many people will be inside when they do. The debt for this cheap construction will be paid not in currency, but in catastrophe. Have you ever seen construction that looks suspicious? Would you trust a high-rise built in 3 days? Let us know in the comments below. If this investigation into the fake concrete crisis shocked you, hit that like button, share this video, and make sure to subscribe to Mega Defect for more deep dives into the systems that fail us